Hi guys, in this video we're gonna talk about probability. If you bet on something, what percentage your bet will be correct? We can use probability concept. Probability is all about the likelihood of an event happening. One more time, probability is all about the likelihood of an event happening. Whether it is flipping the coin or predicting the weather, understanding probability helps us make informed decisions and navigate the uncertainties of life. There are two main types of probability, empirical and theoretical. Empirical probability is the probability based on actual observation or experiments. For example, I toss a coin for 100 times and the tail appears 53 times. So the probability of tails appearing will be 53 over 100 or 0.53. The second one is theoretical probability. It is calculated based on mathematical principle. Like previous example, for example, I have a coin and I want to toss the coin. The probability of tails appearing will be 1 over 2. Theoretical probability is calculated by dividing the number of desired outcome by the total possible outcome. In this case, the number of desired outcomes is the number of tails appearing. It is one option. Divided by total possible outcomes, in this case, two possible outcomes, head and tail. So, the theoretical probability of tails appearing is 1 over 2. It is 50% or 0.5. Next up, let's talk about complement rule. This rule helps you to find the probability of event not happening. The formula is the probability of an event happening plus the probability of an event not happening equals to 1. So, for example, the probability of rain is 0.7. The probability of not rain will be 1 minus 0.7. It equals to 0.3. Is it easy, right? After you know about the concept of probability and also the complement rule, let's talk about mutually exclusive and independent events. If you throw a dice, is it possible for both a dice face 3 and 5 to appear in a single dice throw? It is impossible because it is only single dice throw. Only one option can appear, 3 or 5. It is mutually exclusive event. Mutually exclusive events are events that cannot occur at the same time. There is no intersection. However, independent events are events where the outcomes of one event does not affect the outcome of another. One more time, independent event is the event where the outcome of one event does not affect the outcome of another. For example, in the case of rolling a dice, if the dice show a 3 on the first row, it will not affect the outcome of the second row. In the second row, 3 is possible to appear again. That is independent event. The other example is when you want to flip the coin and rolling a dice in the same time. The outcome of flipping the coin, head or tail, does not affect the outcome of rolling the dice 1 to 6. This is independent event. There could be intersection between these two events because one doesn't affect the other one. After you know about mutually exclusive and independent event, let's learn about rules of addition and multiplication. This is the simple way. Addition is OR, multiplication is AND. Again, addition is OR, multiplication is AND. Related to the probability, if there is a question P, A or B, OR is addition. So just simply PA plus PP, the probability of A plus probability of B. While for multiplication, it is AND. P, A and B, just simply PA times PP. Okay, that's the simple way. But you have to understand whether the event is mutually exclusive or independent. In the mutually exclusive, two events will not occur at the same time, so there is no intersection. For addition, it's simply PA or B is PA plus PP. For PA and B, it is empty set because there is no intersection as we have mentioned before. For independent event, since there is intersection, for PA or B, the formula will be PA plus PP minus PA and B. Don't forget about this. While for multiplication, PA and B equals to PA times PP. So, if I conclude, you have to understand first whether the event is mutually exclusive or independent. Then you can decide the rules of addition and multiplication that you should use. So, if I have the question, what is the probability that a card chosen at random from a standard deck of cards will be either a king or a heart? My question is that, is it mutually exclusive or independent? Is it possible king and heart occur at the same time? Yes, there is king heart, right? So it is not mutually exclusive, so it is independent. Since the keyword is OR, so probability A or B equals to probability of king plus probability of heart minus probability of king and heart. Probability of king, there are 4 kings, so 4 over 52. Now let's find probability of heart. There are 13 cards of heart. It means the probability of heart is 13 divided by 52. Now, what is the probability of king and heart? The number of king and heart in the deck of cards is 1. So, king and heart equals to 1 over 52. So, if it is as the probability of either king or heart, it equals to probability of the king 4 over 52 plus probability of heart 13 over 52 minus the probability of king and heart, it is 1 over 52. The result will be 16 over 52 or 0.3077. The other question, what is the probability of rolling a 3 on a fair 6-sided dice and then flipping a coin and getting tails? So the question is the probability of getting 3 in the dice and getting tail in the coin. The probability of getting 3 in the dice is 1 over 6. There are 1 3 only divided by 6 outcome. While for the probability of getting tails in the coin is 1 over 2. So probability of getting 3 in the dice and getting tails in the coin will be 1 over 6 times 1 over 2. It will be 1 over 12. So the probability will be 1 over 12 or 0.0833. The other question, in a survey of customers at a coffee shop, it was found that 60% of the customers prefer black coffee and 30% prefer espresso, and the rest is other types of coffee. What is the probability that a randomly selected customer prefers either black coffee or espresso? In this case, this is mutually exclusive event because one customer can only choose one preferable types of coffee. So if the customer prefer black coffee, they will not prefer espresso and the other types of coffee. So this is mutually exclusive. Since the keyword here or black coffee or espresso, so we use general rule of addition. General rule of addition for mutually exclusive, directly the PA plus PP. It means the probability of black coffee plus probability of espresso. It is 60% plus 30%. It equals to 90%.